do a little pre-assessment. I had something that I was going to print out and give you guys, but I forgot it, so we'll do it on here. So what do you guys remember? First of all, you guys just finished 9th grade, and were you guys in algebra last year or geometry?
Geometry.
You guys are in geometry?
Yeah.
Do you remember doing some algebra, maybe?
A little bit.
Some graphing?
Mostly.
So this is just some review, I think. Once we move on to parabolas, you guys are going to have to know this.
I have a question.
Yes.
Is the parabola the curve
The
thing?
parabola is the curve.
Okay.
So you know
Good question.
parabolas. Wonderful. So up here's the graph. And just a few terms to remember, which one out of these two is the x-axis? You know? You guys remember? Or which one's the y-axis?
Horizontal one.
Is the which one?
Yeah, the
The
horizontal one.
Is the x-axis? Yeah. So
And
this
the
is
y is the vertical one,
Right.
right?
Right. So where's the origin?
The origin is in the middle of the x and the y-axis.
Correct. So that would be the coordinate point 0, 0, right?
Yep.
So if we were to graph y equals 2x plus 7, there's a few ways we could do that. We could start by plugging in numbers for x and for y, or we could remember maybe how to find the slope and the y-intercept. You guys remember how to do that at all?
Y-intercept is the +7.
Yep, this is the
So
7.
y-intercept-
So the y-intercept is at +7. That means the coordinate point is 7, 0. Or I'm sorry, other way around, right?
Right.
0, 7. I did that wrong. So 1, 2, 3, 4, 5, 6, 7 up here. And then the other element we need is the slope. You guys remember where the
That's
slope is?
changing y over 2 next?
Yeah, yep,
Or the other way
yep.
around?
And where can we find it in this equation?
What are we looking
The
for?
2x.
The 2 is the slope.
Yeah.
So that means,
Seven's right there.
yep, that's the y-intercept. Right. So the slope being 2, I'm just going to do this quickly because it seems like you guys got a good handle on this.
Yes.
Roughly like this.
We were just on summer break, so we're
Yeah.
refreshing.
Right, I can't remember. So, yeah, just simple graphing. So if I was to draw, so we're going to be doing some parabolas. And before we do that though, so what we're doing with our Fun with Parabolas lesson is I made you guys these graphic advanced organizers. So you guys can pick one. You have one
The
hand here.
green one.
The green one and the black one.
I'll pick the black.
I have a copy too. We all have the same thing in here. So on the first page, you will see, I'm going to show this so I can show my teacher too. We have a little word map. So what does it say in the middle? Word, yeah, that's a silly question. So the word of the day for this lesson, what are we learning about?
Definition, characteristics, examples, and non-examples.
Yeah, that's what it says. So we're
Parabolas.
learning about parabolas. Yes, good job. So let's write in the middle, let's write parabola. We're going to talk about vertex and axis of symmetry. So, next
Is
to
vertex the middle?
vertex, yeah, it is pretty much the middle. It's a different way to describe it. So we wrote the definition here, and then characteristics or properties. A parabola has a vertex and an axis of symmetry. So Audrey, you said the vertex was the middle. The vertex is either the lowest or the highest point. So if this was a parabola this way, it'd be the highest point. The point where the parabola crosses the axis of symmetry. Or you could say the middle. It's kind of the middle. Or it's also the lowest point, or it could be the highest point. So what is the axis of symmetry?
It's
The middle. The coordinates.
Yeah, you just, yeah,
The
I
coordinates.
like that. Yeah, like you went like that. It's the goes right down the middle. So for this one, the one I drew, the axis of symmetry is the what? Which axis?
y.
The y-axis. Very good.
It's also like
So what I want you guys to do, let's go through your, let's go through the rest of your organizer. So on the next page, I'll actively show this to the computer here. You have a page for notes. We'll don't need to write anything right now. We'll add some more equations later. The next page I think is pretty neat. I have a little transparency over some graph paper. Mine's blue, but you guys have clear ones. And then with a couple of these dry erase markers, you guys could make some practice graphs. With it, you can add your axes of symmetry on the transparency. You can write on the transparency right there, and make practice graphs. So I ask you to graph something, and then you can just erase it. Well, go ahead, try writing something. Just practice it. Make sure it comes off. So why don't you guys both draw me? You did draw a dinosaur.
I thought you wanted me to draw it.
Yeah, no, now I would like you guys both to draw me an example of a parabola. Just so I can,
So can
yeah, let's just kind of finish up for today. So let's just go over your graphic organizer again. So today we added our word and definition of parabola, characteristics of a parabola. Actually, while we're at it, at the examples part, why don't you guys just draw an example? Here, I just want you to either write something out or draw pictures. Yeah, why don't you, that's perfect. Draw a parabola down here. You can draw your parabola too. Over in this part, on the first page. And there you go. Awesome. And then after this section, there's extra graphing paper. We'll be doing some more problems tomorrow and the next day, and then places to take note. Okay. All right. Welcome back to lesson 2 of Fun with Parabolas. So yesterday we reviewed just what a graph is, how to graph a basic line, explored, I see you're looking through your organizer. Good job. Started to explore parabolas. So a parabola is a what? Can somebody maybe open up their graphic organizer to the first page?
It's an arch or a curve.
Yeah.
Is what a parabola is.
Yep.
It's an anomaly between the two, the vertical and the horizontal line that
Anomaly.
represent. And the parabola is the anomaly. That
The arch?
causes arch, yes.
Yeah, so it's an arch. The official definition we said was the arch-shaped curve with points equidistant. What does equidistant mean? We didn't write that down. What does equidistant mean?
It means they're the same distance.
Same distance from,
Same
yeah.
distance.
From the vertex and the axis of symmetry. And then we added those two terms under characteristics. What's a vertex? For
It's
instance?
the middle. It's
Yeah.
like the lowest or highest point.
If I showed you this one, the lowest or highest point, that's also, the middle. Doing this backwards on the camera. And then axis of symmetry, what does that refer to?
The
It's-
middle of the
yeah,
horizontal
it's
vertical
like
line.
that. It's also kind of the vertex
Yeah,
in a way.
So if I drew this parabola, I'm using a whiteboard marker this time, where would the vertex be?
The vertex is the one
It's
crossing that way.
Here's the vertex.
Yes.
Right. Kind of think of it as the center point, or the lowest point. If a parabola was like this, it's not done very well. Oh, that's horrible. It would be up there, right? Axis of symmetry would be where? Straight down right there. And then, yeah, feel free. You guys don't have to raise your hands since we have a small group. You guys can call out some answers respectfully. And just remember, with math, it's hard sometimes. It sounds like you guys, a lot of this is review, but sometimes, you have to relearn skills, and some people might learn it quicker than others. So it's always good to encourage people. I know when I was preparing for this, I still had to relearn some things. So review is always good. So yeah, today we're going to talk about what happens when you see the parabola written in an equation like this. There's two ways to how to write a parabola equation. One is the standard vertex form, which is this, a whole bunch of variables. On the second page in your graphic organizer, or the advanced organizer, where there's just a blank notebook sheet, I want you guys to write out this equation. So flip it to the next page. One of the lined papers, there you go. I want you to write y equals a, and in parentheses, x minus h squared plus k. Yeah, there's the pen for you. So today we're going to learn what h and k stand for. So when you see a parabola written out in vertex form like this, the first thing you want to do, well, just like any graph, like the one we reviewed yesterday, like using slope-intercept form, or any graph, you can always just plug in values. If you wanted to see when x equals 0, what y equals, you could go through all the algebra there. Or this makes it so simple. H and k shows us exactly where the vertex is. So h tells us which way, left or right, the vertex moves.
The horizontal.
Yep, and k tells us which way, up or down, it moves. So we're going to think of it like this. It's my graph of my parabola, y equals x squared. If the value of h right here, and we're not going to look at the negative sign in front of it. This is just going to be a positive absolute value h. If the h here was the number 2, it would go right 2 units. I don't have units written out here. And what if k was 6?
Go that way.
Remember, k makes it go up or down.
Up, yeah.
We go up 6.
Units.
In the standard vertex form. Voila. Y equals a x minus 5 squared plus 3. So here's my parabola. It's ready to move. So x minus 5 squared plus 3. Where am I going to go? First of all, let's
You
look.
would go to the left, 5 to the left,
What
and then up 3.
Okay, so let's compare it to this form up here. Still in the x minus h form. So this, remember, it's tricky. You got to think of it backwards. Are we going to the left or right?
Beneath the horizontal.
Remember, h we go left or right?
You would go left, because it's negative.
Right,
When
but
it go below the line, because it's negative.
remember,
No,
h makes it go
because
left or right.
there's still the negative on the left side of the graph, because that and below.
But we think of it as backwards. So even though it's minus 5, it's just messed up. Yeah, we're gonna go to the right 5. That's just how this form works. And then we're going to go up or down 3.
Down,
3
down 3.
squared.
Are we going up or down 3?
You can't go up, so down 3 squared.
Yep, we're going to go up 3.
You could go up. Why could you go up?
It's just tricky. I know it's tricky to think of.
Could I ask a question?
Why
Yeah.
would that be reversed? If it's minus
yeah, why
on the
would it
bottom,
go-
but you
yeah,
still
I had
go
the
to
same
the right,
question.
why would the second half be positive, but you still go up?
Because it follows this form.
But it's still the same. It's a positive for that, and it's a positive for that. So therefore, we're trying to ask, like, why is it not a negative? Or
No, okay. Because if with minus 5,
Mm-hmm.
it should go
you
down.
go to the right,
Mm-hmm.
but plus 3, you go up.
Mm-hmm. You
So
just,
only
it's
one of
just
them
a
is
rule.
reversed.
It's just a rule that the h is backwards. That's just the rule.
Okay. Whatever you say.
So, I mean, we can even plug it. All right, great job, guys.
Thank you.
Thank you.
So,
Miss Katie.
you're welcome.
Thank you for teaching us.
I've learned lots about parabolas.
So what-
and
we're not even done yet.
Equations.
We're not even done. We have more to learn about tomorrow.
Okay.
So,
Yeah.
yep. We're wearing a different shirt tomorrow. Experience. So yeah, so today what did we learn?
About
Parabolas.
parabolas.
Parabolas can move, right?
Parabolas can move, and they can also be associated with things other than math, like social situations and politics.
Well, yeah, that's what math does. Math is a language to describe what happens in the world around
That's
us.
why
So
you
yeah,
need
absolutely true.
So to me,
All
I
right.
learned that parabolas.
Defined and identified characteristics of parabolas. We've talked about what a basic y equals x squared parabola looks like and how when it flips it turns negative. We talked about how the vertex moves and how we write the equation for that. So let's just review that real quick. So it's the last thing we did yesterday and it's pretty important and we're going to move on from there. So in the vertex equation that you guys have written down, the y equals a x minus h squared plus k. What does the h do? Which way does it?
Horizontal.
Yep, h. Yeah, that's a really good way to remember it too.
H is horizontal.
H is horizontal. Awesome. And so k makes it go which way? Up and down. Is there an acronym or something we can think of? K makes it climb,
Oh, yes.
perhaps?
Like a mountain.
Right, yeah. Way to expand on that. Yeah, so H makes it go horizontal, K makes it climb up or down. I really like
Like
that.
kilometers, because if you're climbing a mountain, you like
You need
Everest,
5
you
kilometers.
Yeah,
climb kilometers.
sure.
So
Because we got the right metric system. Shut up.
So those are the two variables that we've talked about, besides x and y. So today we're going to focus on A. So let's think about what a parabola. Wonderful math-related segue there. It's the second time I've talked about segues today, but the first time was about the actual segue. Anyways, so what's the role of A? Here's, our basic y equals x squared parabola that can move.
Is A kind of like the slope?
You know what? In a way, kind of. Let me just draw you guys a parabola to show you what A can make a parabola do. Am I using the right marker this time? Oh, here we go. So we know that a parabola can change direction, transfer points, or transfer across the graph. What about this parabola, the one on the outside? What's different than the one on the inside? What happened to this parabola?
It's chaotic.
No, just the one out here.
It got wider.
It got wider.
Yes,
Oh.
it did.
Yeah.
That's what I meant by chaotic.
Parabolas can get wider. Parabolas can get,
Smaller.
yeah, narrower. So that's the role of A. A makes a parabola
Be obtuse
widen.
or acute.
Yeah, widen
Obtuse or acute.
or narrow. And what A does, so the role of A is kind of inverse. You have to think of it backwards, kind of like the H. If as A gets bigger,
Does it get wider?
as A gets bigger,
It gets smaller.
yes, parabola gets narrower. As A gets smaller than 1, it gets wider. So, let me just use this here. So here's our graph of y equals x squared. Now we don't have any h or k variables, so it's staying right at the origin. But now a is the number 2. Is 2 larger or smaller than 1?
Larger.
So if a is larger, the parabola gets,
Small.
yes, so that would be this one here. What if it is, try writing upside down, y equals 1/2 x squared. Is 1/2?
It get larger.
Yep, it's smaller than 1, so the parabola gets larger.
Yeah.
Ta-da! So what I want you guys to do is you guys can look together at this graphing worksheet, and I can find it. So what we have here, we have 4, and I'm just going to show the computer so my professor sees it. We have 4 graphs and a multiple choice, 4 equations. I want you guys to match up the equations to the graphs based on what we have just found out about what A is.
Okay.
So see if you guys can do that.
This one? No.
Wait, I have my legs crossed.
This one is D. This one is C.
What does that say? That's the equation.
Wait, no.
Y equals 1/3
That's
times
no.
squared.
This is C. This is D. D. That one is B, and this one's A.
Awesome, let me see. Okay, so the first equation, y equals 3x. 3 is larger or smaller than 1.
Larger.
So which makes-
it would be small.
Yep. And does the parabola open up or down? Is it,
Down.
or it opens
one goes
up because,
That one goes
yeah, it's positive. Yeah, it looks like you guys have a good grasp on this. And correct answers. Good job, you guys.